Hello everybody. Now I am going to give you a presentation on sensors and transducers. Coming to the contents which are present in this presentation: introduction to sensors and transducers, RTD, thermistors, LVDT, strain gauge, piezoelectric transducer, Hall effect sensor. Introduction to sensors and transducers. A sensor is defined as an element which produces signal relating to the quantity being measured. It is a device which produces signal relating to the quantity being measured. It is a device, sensor is a device which provides usable output in response to a specified measurement. The output of a sensor is usually an electrical quantity and measurement is a physical quantity. That is, sensor is subjected to physical quantity. Here measurement means the quantity to be measured. The quantity to be measured is called measurand. The quantity to be measured is a physical quantity. Let me move on to the definition of a transducer. I'll give you a clarity about the sensor a little bit later. Okay, now coming to the transducer. A transducer is a device which transforms a non-electrical physical quantity into an electrical signal. In general, it is defined like this: a transducer is a device which transforms one form of energy into another form. It is a device which converts one form of energy into another form. Okay, here see. A transducer is any device. Is any device. It is a device which converts one form of energy into another. Coming to the examples of transducers, microphone. It is also a transducer. Electric bulb, microphone, motor or generator, electric motor, microphone. Microphone converts sound into electrical pulses. Sound into electrical impulses. And loudspeaker is also a transducer. It converts electrical impulses into sound. That is converting one form of energy into another form. A transducer is a device which converts one form of energy into another form. Okay, microphone is a transducer as it converts sound energy into electrical impulses, electrical signals. Sound energy is being converted into electrical signals, converting one form of energy into another form. So, microphone is a transducer. Loudspeaker is also a transducer because it converts one form of energy into another form, electrical signal into sound energy. Okay, solar cell. It takes solar energy and that is being converted into electricity. So, solar cell is also a transducer. We know transducer is a device which converts one form of energy into another form, light energy into electrical energy. As it converts light energy into electrical energy, so it is called a transducer. Solar cell is a transducer. A thermocouple is also a transducer as it converts thermal energy into electrical energy. Incandescent light bulb is also a transducer. It converts electrical energy into light energy. Okay, electrical energy into optical energy. Light bulb is a transducer for converting electrical energy into optical energy or light energy. Of course, it also produces heat. converts electrical energy into heat energy. You can also say like this. An electric motor is also a transducer for converting for converting electrical energy into mechanical energy. Motor is a machine which converts electrical energy into mechanical energy. That's why it is a transducer. Electric generator is also a transducer which converts mechanical energy into electrical energy. Okay, all are examples of transducer. All are examples for transducer. Coming to sensor. As of now, we came to know about a transducer. A transducer is a device which converts one form of energy into another form. Okay, coming to a sensor. A sensor is a device that receives and responds to a signal. Receiving signal is nothing but detecting signal, which detects some signal. A sensor is a device that receives and responds to a signal. The signal must be produced by some type of energy such as heat, light, motion or chemical reaction. Okay, sensor is a device that may detect heat energy, light energy, motion or chemical reaction. Okay, the signal which can be received by this sensor may be produced by some type of energy such as heat, light, motion or chemical reaction. Once a sensor detects one or more of these signals, it converts it into an analog or digital representation of the input signal. Okay, so sensor is a device which detects some signal. Detecting signal means receiving signal, and responding to a signal means that signal is being converted into an output with readable format. Okay, so sensor detects signal. Receiving signal means detecting signal. After detecting the signal, that sensor converts the signal into an analog or digital representation of the input signal. That is, that signal is being converted into an output with readable format. With readable format. Okay. Now, what are the sensors that you are familiar with or use daily? Eyes, ears, tongue, nose, hand, or skin. Uh, Skin. Okay. Eyes, ears, tongue, nose, skin. It's better to say skin. Okay. All are five sensors. Human beings are equipped with five different types of sensors. Your eyes will detect light. This is receiving some signal. Your ears will detect sound. Tongue and nose will detect chemicals. Okay. Ears will detect acoustic energy or sound energy. Our skin detects pressures, temperatures. Okay. All our sensors. Human beings are equipped with 5 different types of sensors. CRT, cathode ray tube, it is also a transducer because it converts electrical energy into light energy for a visual output. Okay, it converts electrical energy into light energy for visual output. That's why it is a transducer. CRT is a transducer. Sensors detect the presence of energy. You know, sensor is a device that receives signal and responds to a signal. It is a device that receives and responds to a signal. I'll give you a clarity about this point. Let me give some more clarity about that point. Sensors detect the presence of energy changes in or the transfer of energy. Okay. Sensors detect by receiving a signal from a device such as a transducer, then responding to that signal by converting it into an output that can easily be read and understood. Okay, that is, sensor is a device that receives signal which is produced by a transducer. Sensor is a device that receives signal that signal is produced by a transducer and responds to a signal. Responding to a signal means by converting responding to the signal means converting that input into an output with readable format. Okay, so typically sensors convert. Okay, normally receive signal sensors will receive signal and respond to that signal. Okay, sensor is a device which receives and responds to a signal. Detecting signal means receiving signal. Response to a signal means the signal which is received by a sensor is being converted into an output with readable format. Okay. Typically, sensors convert a recognized signal into an electrical analog or digital output that is readable. This is the meaning of responding to a signal. Okay, sensor will detect signal or receive signal, and that signal is being converted into an output with readable format into an electrical analog or digital representation. Transducer convert one form of energy into another. The difference between these two, what is the difference between sensors and transducers? Coming to the difference between sensors and transducers. Transducers convert one form of energy into another form, but they do not quantify the conversions. They do not quantify the conversions. For example, you take generator. Generator is a transducer. It converts mechanical energy into electrical energy, but it doesn't quantify the conversion. Means it doesn't tell you that how much energy is being produced, how much electrical energy is being produced. just it converts one form of energy into another form, that is mechanical energy into electrical energy, but it will not tell you how much energy is being converted. It doesn't tell you the amount of energy produced, amount of electrical energy produced. Okay, see, the light bulb converts electrical energy into light energy. However, it doesn't quantify how much light is produced. It doesn't quantify how much light. That is, it doesn't tell you that how much light is produced, light is being produced. Just it converts one form of energy into another form. Okay, so transducer is a device which converts one form of energy into another form, but they do not quantify the conversions. Transducers convert one form of energy into another form, but they do not quantify the conversions. A battery converts chemical energy into electrical energy, but it doesn't quantify exactly how much electrical energy is being converted. It doesn't tell you the amount of electrical energy produced. It doesn't give you the amount of, I mean, it doesn't provide you the, it doesn't provide you the amount of electrical quantity being produced. It will not give you the information about the amount of energy produced. That is, it doesn't quantify. Just it converts chemical energy into electrical energy. You don't know how much energy is being converted. How much energy is being converted. So transducers convert one form of energy into another form, but they do not quantify the conversions. If the purpose of a device is to quantify an energy level, it is a sensor. Transducers do not quantify the conversions, but sensor does. Sensor is a device which is used to quantify the conversions. It quantifies the conversions. Now, coming to this, you take skin. Skin is a sensor which receives signal. Okay, suppose some hot plate. If you touch hot plate, your brain will tell you that the hotness of the plate. That is, a sensor is a device that receives signal and responds to a signal. Okay, responding to a signal means that signal is being converted into an output with readable format. Okay, sensors do quantify. Sensors do quantify the conversions. Okay, so when you touch a hot plate, it is your brain that tells you it is hot, not your skin. Your skin will not tell you the hotness of the plate. Okay, that is, your skin sense the hotness of the plate, and gives the information to your brain, so that your brain that tells you the hotness of the plate. If it is more hot means, after touching this plate, your brain will tell you that this plate is more hot. If it is less hot means, your brain will, after touching this plate, your brain, after touching this plate, when you touch this plate, if your skin touches this plate, touching this plate means it is sensing heat. After sensing heat, or after detecting heat, it sends information to your brain. Then your brain will quantify the output. Your brain will tell you the hotness of this plate. Okay, now coming to temperature sensor. Here we have two types of thermometers. This one is digital readout thermometer and this one is mercury thermometer. Coming to this mercury thermometer, it is a sensor, temperature sensor. A thermometer senses temperature, senses temperature and converts temperature into a readable output. Thus, it is a sensor. A mercury thermometer, I am taking this. If I take a mercury thermometer, which uses a level of mercury against a fixed scale, is a direct output. Depending upon the level of mercury, you will come to know the reading of temperature. You can measure temperature with the help of level of mercury. Level of mercury will get changed when this thermometer is subjected to temperature. Okay, that is coming to this digital readout thermometer. A digital readout thermometer gives indirect output. Okay, for a digital readout thermometer, a converter is used to convert the output of the temperature transducer to an input for the digital display. That is, here in this we use thermocouple. It is a transducer as well as sensor. Here it is a sensor. Okay, now coming to digital readout thermometer, it is both a transducer and a sensor. Usually we use thermocouple, which converts heat energy into voltage and quantifies the output with a readable format. You can have the digital display over here. The mercury thermometer utilizes mercury property of expanding or contracting when heated or cooled, respectively. You know, with the increase in temperature, the mercury level will be increasing by utilizing the property of expanding. Okay, so the thermal energy from the temperature increase is transferred into the mercury thermometer. So level of mercury will be expanding in thermometer. The expansion of mercury is scaled to numbers on the tube indicating the temperature. Okay. Ohmmeter measures resistance. Voltmeter measures voltage. Galvanometer measures current. Watt-hour meter measures the amount of electrical energy supplied to and used by a residence or business. Okay, so You take voltmeter or galvanometer. You take galvanometer. It is a sensor. This receives signal. This receives electrical signal, and that signal is being converted into an output with readable format. Okay, you can have reading over here, right? So it is a sensor. And one more thing is, it is also a transducer because motoring principle is being involved in this galvanometer. So it is also a transducer. You know, transducer is a device which converts one form of energy into another form. Okay, here instead of this galvanometer, uh, we use motoring principle. So this converts one form of energy into another form. Okay, that is electrical energy into mechanical energy. So you are going to get the reading. Okay, so it is a transducer as well as a sensor. Why it is a sensor? Just it receives signal, it receives electrical energy, that is it is receiving signal. Responding signal means which quantifies the conversion, means which that signal is being converted into an output that is readable, converting it into an output with readable format. You can read out the value. Okay, now coming to resistance temperature detectors. RTD works on the principle that the electrical resistance of a metal changes when the metal is subjected to temperature. Due to the change in its temperature, the resistance of the metal will be changing. On heating up elements, the resistance increases and follows a linear relationship as shown in figure. The relationship between resistance and temperature will be like this, depending upon the metal, depending upon the type of metal being used. Okay, you're going to have different relationships like this. For nickel, you're going to have relationship like this. Okay, for platinum it is almost linear. You're going to have relationship like this for copper. Temperature versus, sorry, resistance versus temperature. RT by R naught with respect to temperature. Here this is RT. The relationship between temperature and resistance of conductors can be calculated from the equation. Okay, we have equation. This equation gives the relationship between resistance and temperature. RT is the resistance at T degree centigrade. R naught is the resistance at 0 degree centigrade. Alpha. Alpha is a constant for the metal termed as temperature coefficient of resistance. Alpha is temperature coefficient of resistance. It will be changing depending upon different metals. It will be different for different metals. It is constant for the metal termed as, it is constant for a particular metal, and it is termed as temperature coefficient of resistance. For any particular metal, this alpha is constant. This alpha is called temperature coefficient of resistance. Okay, now resistance temperature detectors. Coming to the construction of a RTD, it has a resistor element. We have resistor. It has this RTD is having a resistor element connected to V-stone bridge. Connected to a V-stone bridge. The element and the connection leads are insulated and protected by a sheath. Insulated and protected by a sheath. A small amount of current is continuously passing through a coil through this resistance. Then temperature will be changing. Temperature of this resistor will be changing. Okay, with the change in temperature, resistance of this coil will be changing. That change in resistance is detected by V-stone bridge. RTDs are used in the form of thin films, wire wound or coil. They are generally made of metals such as platinum, nickel or nickel copper alloys. Coming to the applications of RTD, air conditioning and refrigeration servicing, furnace servicing, food service processing, medical research, textile production. Thermistors. It is a semiconductor used as temperature sensor. Thermistors are available in the form of bed, pressed disc, chip. It is a mixture of metal oxides pressed into a bed or other shape. Beds can be very small, less than 1 mm in some cases. Okay, it is having negative temperature coefficient of resistance. Thermistors will be having negative temperature coefficient of resistance. Means with increasing temperature, resistance will be decreasing. Okay, so coming to the relationship between resistance and temperature, okay, it is inversely proportional to the temperature. Coming to linear variable differential transformer, LVDT. Linear variable differential transformer, that is LVDT, is a primary transducer used for the measurement of linear displacement. With an input range of about 2 to 400 mm in general. It is equipped with two windings. It consists of basically two windings, primary winding and secondary winding. Okay, you're going to have two secondary windings. Two secondary windings wound over a hollow tube and positioned. These two windings are positioned so that the primary is between two of its secondaries. In between two secondaries, you're going to have primary winding. Okay, you're going to have ferrite core. Okay, this is primary winding. You're going to have only one primary winding and two secondary windings. Okay, ferrite core. In between these two coils, you're going to have ferrite core, armature core, or iron core. Okay, here you're going to have two windings, two secondary windings. Now, here you're going to have series opposing connection. Here, series opposing connection. On secondary side, you're going to have series opposing connection. Means total voltage on secondary at secondary V is equal to V1 minus V2, because these two are opposing each other. When these two are opposing each other means V1 minus V2. Voltage at this point with respect to this point will be equal to V is equal to V1 minus V2. Okay. Now, if it is at center, V1 will be equal to V2. Okay. Now, here V is equal to V1 minus V2. If this is at center, if this core is at center, V1 is equal to V2, then V is equal to 0. So at center, if the core is at center, V1 is equal to V2, then V0 is equal to 0. Output on secondary side is 0. If this core is moving towards S1, S1 is one of the windings. If core is moving towards S1, then V1 is greater than V2. If V1 is greater than V2, then V is equal to V1 minus V2, then this will be greater than 0 because V1 is greater than V2. If V1 is greater than V2 means V will be positive. V will be positive. Okay, if V2 is greater than V1, then V is equal to V1 minus V2 less than 0. Okay, that is, see, when the score is at center, V1 is equal to V2 and V is equal to 0 as V is equal to V1 minus V2. If both are equal means V will be 0, output voltage will be 0. If it is moving towards S1, then V1 will be greater than V2, then V is equal to V1 minus V2, that will be greater than 0. Means if it is moving towards S1, voltage will be increasing in forward direction. V0 will be increasing. If this core is moving towards S2, then V2 is greater than V1. If V2 is greater than V1 means you're going to have negative voltage as output. Then voltage will be increasing in reverse direction. Okay, if it is at center, voltage will be 0 because V1 is equal to V2. If core is moving towards S1, V1 will be greater than V2. Then total voltage will be positive and constant. So voltage will be increasing like this in forward direction. If this core is moving towards S2, then voltage will be increasing in reverse direction as V2 is greater than V1, then V will be less than 0. Coming to strain gauge. The strain is an element, is a ratio of change in length in the direction of applied load to the original length. Okay, delta L by L. It's called strain. This is without strain. With strain, you're going to have wire like this. Okay, with strain means uh, if you stretch this length of wire and this will become like this. If you stretch this wire, then this length of wire will become like this, and the length will be increasing if you stretch this wire. If you stretch this wire, the length will be increasing. Okay, you know R is equal to rho L by A. R is resistance, rho is specific resistance of the conducting material, L is the length of conductor in meters, A is the area of cross-sectional area of the conductor. L increases and A decreases, then R will be increasing. R will be increasing. If you stretch this wire, then L will be increasing and A will be decreasing, so R will be increasing. Okay. L increases, A decreases means R will be increasing. The change in resistance can be detected by using a Wheatstone bridge. Okay, Rx. Okay, Rx is the resistance of strain gauge element. Okay, this can be measured using Wheatstone bridge. Okay, you know, under balanced conditions, you're going to have the formula like this. You're going to have this formula. Okay, here R2 is adjusting variable resistor. R2 is variable resistor, and these two are fixed values. and you can find this value. Coming to gauge factor, K is equal to delta R by R delta L by L, where delta R is the change in resistance, R is original resistance, delta L is change in length. Okay, L is original length. Okay, so K is equal to delta R by R by delta L by L. You know, change in length to the ratio of change in length to original length is strain. Okay, that is indicated by G, delta R by R by G, that is gauge factor. Okay, coming to piezoelectric transducer. Okay, here we have piezoelectric material. If we apply some force on this or pressure on this material, then electricity will be produced. If I apply some force or stress, some pressure on this piezoelectric transducer, then voltage will be produced. That can be measured by using voltmeter. Okay, so this voltage is function of the force or pressure applied to it. Okay, if I apply pressure or force on this piezoelectric material, voltage will be produced. That is about piezoelectric transducer. Coming to Hall effect sensor. Hall effect sensor works on the principle that when a beam of charged particles passes through a magnetic field, forces act on the particles and the current beam is deflected from its straight line path. Thus, one side of the disk will become negatively charged and the other side will become positively charged. That is here seen. Let me take one disk. Let me apply some voltage on this disk. Let me apply some voltage to this disk. DC voltage applied to this disk. Then charged particles will be flowing from here to here. Okay, that is you are not using any magnetic field over here. Okay, just you are applying some voltage, then charged particles will be passing through this circuit, and these charged particles will follow a straight line path. They follow a straight line path. Okay, now what I'm going to do is now I'm applying some voltage. Okay, after applying some voltage, sorry, okay, let me place magnet upon this disk. Okay, so because of this magnetic field, magnetic line forces act on the particles, charged particles, and these charged particles will get deflected from its straight line. These charged particles will get deviated from its straight line. Okay, so when you place a magnet upon this disk, because of magnetic lines of forces, these charged particles will get deviated from its straight line path. When these charged particles deviating from its straight line, then potential difference will be created. Potential difference will be created across the disk. That is, one side of the disk will get negatively charged and the other side will become positively charged. Okay, that is, this will become positive charge and the other side will become negatively charged. So potential difference is created. Okay, so because of this magnetic field, charged particles on the disk are deviating from its straight line, and one side of the disk will get positive charge and the other side of the disk will get negatively charged. That is, potential difference is created. So this charge separation generates a potential difference, which is the measure of distance of magnetic field from the disk carrying current. Okay. So this is the working principle of Hall effect sensor. Okay, when you apply magnetic force upon this disk, these charge particles will get deviated from its straight line, so that potential difference will be created. Potential difference will be created. This charge separation will create potential difference. Coming to the applications, a typical application of Hall effect sensor is the measurement of fluid level in a container. Fluid level in a container. Okay, the container comprises of a float. Okay, you're going to have flow of liquid like this. Flow of liquid like this. Uh, the container comprises of a float. Okay, let me have turbine like this. Armature wheel. Sorry, turbine wheel. Don't have. Let me have turbine. Turbine wheel. This is turbine wheel. Okay. The container comprises of a float with a permanent magnet. Okay, here you're going to have permanent magnet. This is permanent magnet. Okay, permanent magnet. So you're going to have permanent magnet. Permanent magnet. Permanent magnet is attached at its top. Okay. An electric circuit is an electric circuit with a current carrying disc is mounted in the casing. Okay. Here you're going to have uh, here you're going to have you're going to have Hall effect sensor circuit. Hall effect sensor circuit. That is, you're going to have disk and you're going to apply some voltage to this disk. You're going to apply some voltage to this disk. Okay. Now, when the fluid level increases, okay, if the flow of water is more, if the flow of fluid is more, okay, then it will move in upper direction. This float, this turbine will move in upper direction. Okay, this water will move this turbine in upper direction. Okay, so when the fluid level increases, the magnet will come closer to this disc. Okay, you're going to have all effect sensor circuit over here upon this. Okay, the moment the flow of water is increasing, it will move in upper direction. That is, it is this permanent magnet is coming close to this disc, coming close to this disc. When this is coming to close this disc, because of magnetizing force, potential difference is created. Potential difference is created across this disc. One side of disc will get positive charge and the other side of disc will get negatively charged because of charge separation. Okay, so that potential difference triggers a switch to stop the flow of fluid. This potential difference is being used to trigger a switch to stop the flow of fluid. Okay, this is one of the applications of Hall effect sensor. Okay, these sensors are used for measurement of displacement and the direction and the detection of position of an object. Thank you.